Okay, we're back with, I figured out what I did wrong pretty quickly. I can show you the timestamp on this. It was right away. You've probably already figured it out because you are a UCF student and you're going to be a doctor, and you're like, Danny, you're missing something very important in the numerator, and really the whole construction of, let's say, a power series in general. We have to have a negative sign. So I want to show you how to use Bing. You type in Poisson applet, and I don't know what happened to Java. Java doesn't work anymore, but this one, the University of Iowa, they have stellar statistics program. I believe they're really good, and I'm always on their website. I'm going to plug in here for the rate parameter 10, right? I've at least done that correctly. And then, right, they say on average. No, I didn't even do that correctly. Nope. Nope, we're going to let this video stand as a, it is what it is. This is actually the 20th incarnation of this problem. I just keep doing it until I get it right. Which is really, I'm modeling for you the way to approach these kinds of things. I mixed up, I'm really doing everything wrong that you could possibly do wrong on one of these problems. Just what happens when you have to take an extra step like converting. Everything gets all messed up. I really don't have any excuses, so let's just go ahead, and you've turned this video off. Nobody's watching anymore because you already have the answer. This is what happens when you you just don't know what you're doing. Let's figure out what lambda is. Lambda is the average. I gotta go back to basics here. Lambda is the average number of occurrences in a given place or time. It's often used to for rare phenomena. You might, if you Google Poisson distribution, use one of the links I've provided. How often, not how often, how many hits in a particular time or place. Okay? I guess the only thing that was true in part one of this video was the story about horses and friendly fire and the model being built off of that. Well, that probably wasn't even true. It was like unicorns or something. But the a dead giveaway for Poisson versus binomial. I at least know this since I've written 50 exams with this sort of stuff. Is average. It's like, hey, I'm an average. It's like, okay, got it. It's Poisson. You can really just go through the assessment and Poisson, binomial, Poisson, normal, uniform, exponential. Well, we won't deal with exponential, but uniform, normal. But I have 22 decades here is the average, and I want to stick with that. So again, just another demonstration of all the things that could go wrong. I should go back in and edit this and say this is how to make mistakes, which are good because you learn from them. Some people do. It's just label everything at the beginning, right? Like, at least I ended up with the random variable at some point, right? That was only after some story time. We want to know, hey, what's the probability that x equals this pause is on purpose, this one. Not 100 years, but 10 decades. So we've come full circle. Okay, so we just distilled the whole problem into this and this. And now it's time to see if I can get the formula right. So we're going to find this probability, the probability that x equals 10. I'm going to follow my mnemonic. I know that that goes down there, and I'm used to writing e to the negative lambda, and then I write lambda again times, and then I know that x power goes up there. That's my little move. Again, no excuses for what happened the last problem. Well, I'm probably going to delete that so you don't even know what I'm referring to. This is just how to do it right here. You've got it down. So I'm just going to plug in the bits and pieces here. E, who knows? That's going to have to get raised to the 22nd power, and you should make sure to put a negative sign on it. Otherwise, you get the wrong answer. Lot of fun wrong stuff there on that problem. Times 22 raised to the 10th divided by 10 factorial. All right. So the answer is pause. It's actually the same answer as before, so I guess it didn't go that wrong. 0.002. That's good, 3 decimal places. And let's verify that in real time by clicking on my favorite website, where now I'm going to label lambda correctly. It's 22 years, and then I'm going to press this, and it's going to go a normal curve. And notice there's not a whole lot of area around 10. Yes. Enter. I highly recommend these applets for learning, of course. The exam, you wouldn't be able to use them, but in real life, of course, you would be able to use them. But on the performance assessment, you won't be able to use them. This concludes probably the worst Poisson distribution series that is probably available. So see you on the next problem about Andre, former graduate teaching assistant of mine, came up with this problem about John Legend. So we'll stop there. See you in a minute.